Here's the next question, number 16. Consider a HVDC link which uses thyristor-based line commutated converter as shown in the figure. For a power flow of 750 megawatts from system 1 to system 2, the voltages at the two ends and the current are given by V1 is 500 kilovolts, V2 is 485 kilovolts, and current I is 1.5 kiloamps. If the direction of power flow is to be reversed, that is from system 2 to system 1, without changing the electrical connections, then which one of the following combinations is feasible? Now, because of lack of space, I did not write down the options in this page. I wrote it down here. So, we have different combinations of V1 values, V2 values, and I value. Now, if we look at the figure given, we have system 1, system 2, V1 towards system 1 side, V2 towards system 2 side, and the current moving from 1 to 2. Now, the question says, what if the direction of power flow is reversed? So, in that case, here's a very rough diagram. We have our voltages V1, V2, and for the power flow to be reversed, our current is to be reversed as well. The important point here to remember in case of an HVDC link is that if the current is reversed or if the power flow is reversed, the current must remain the same, which means that it must have the same polarity. So current I is the same as 1.5 kiloamps as given in the question. The question says that the current is 1.5 kiloamps. So if it is reversed, the value remains the same. It is 1.5 kiloamps. This doesn't change, which means that there is some change in the voltages. So in general, we have the current formula for an HVDC link from one system to the other as V1 minus V2 by R. This is the general equation, V1 minus V2 by R. So, if we are to look at the options given to us, A, B, C and D, we have to make sure that this entire value, V1 minus V2 by R, must be positive or non-negative in that case. So, if we take V1 as minus 500 minus of minus 485 will give us a negative answer. So, A is out. Now, either way C and D are out because the currents here is minus 1.5 kiloamps and we have established that the current must be positive 1.5 kiloamps. So, C and D rule out, which means that B is the right answer. Since V1 is minus 485 kilovolts, we can work it out and see. So, we have minus 485 minus of minus 500 divided by R. Now, regardless of what value the R is, the numerator, if it is positive, then the result is also positive. So, minus of 485 plus 500 will give us a positive value, which means that option B is the right combination. So, those are the feasible values of voltages for this system given to us when the power flow has been reversed from system 2 to system 1. Well, I hope this explanation has helped.